Okay, so we're still on page 38. Ryan had a 15-meter head start on Luke. How long will it take Luke to catch up with Ryan if Ryan's rate is 70 meters per hour and Luke's rate is 100 meters per hour? Okay, so we drew this picture over here. Ryan had a head start. So Luke started here, went completely to point B. Ryan started here and went to point B. So we determined that we have to add the 15 to Ryan's distance to catch him up to Luke. Okay, we know that Ryan's rate is 70 and Luke's rate is 100. We don't know anything about the time, but we can assume that the time they started was the same time. Even though Ryan was ahead, they started at the same time and they ended at the same time. When the problem tells you absolutely nothing about the time, assume that they're equal. So we're assuming that Ryan's time is equal to Luke's time, and we'll see how that helps us in a second. Because we don't know the distance in Ryan, but we know that it equals RT. And we don't know the distance of Luke, but we know it equals RT. Okay, is everybody still with me? Mm-hmm. Okay, so let's look at what we know. Do we know the rate of Ryan?
70.
Do we know the rate of Luke? Okay, now we have a problem. What have I told you to look for when we get to this point?
What you can
Simple.
yeah. What you can,
There's still something else you need to look for when you get to this point, because if you've got one situation, we've got a problem. What's the problem here?
nothing matches.
What do you mean nothing matches?
You can't simplify anything.
I can't simplify anything because I've got two different variables. I've got a TR and a TL. I can't combine those. But what do I know?
So we should just label it insolvable problem A.
Nope. What do I know?
I don't know.
What do I know about the time of Ryan and the time of Luke?
Equal.
That they're equal. So I can get rid of these because they're the same.
Oh.
So now I've just got T's there. So now what can I do?
Move the 70 over.
Bring that 70 over and do what with it?
Subtract.
So what do I have?
13 equals 30.
Now be very careful here, because what does your brain instantly tell you that the time is?
Do 1/2.
Is that what your brain instantly says? Because my brain looks at that and instantly says what, Thomas?
Divide.
2. Looking at that, your brain probably instantly says that's 2, but that's not correct.
Why would it be 2?
Because you're moving the 30.
Because you look at the 30 and the 15 and you think 2.
15, I thought that was
So I've got to get rid of this 30, so that's going to go here, which gives me 1/2 hour for their time. You see that?
So 30 minutes?
Yeah.
Okay. We're going to say 30 minutes, not 1.
But if you do that, then you're going to have a problem because your rate is in meters per hour. So you need to put your time in the terms of hours.
Yeah, bring me in.
Okay, so now we just do what's half of 70?
35.
What's half of 100? Is there a 15-meter difference there?
Yes.
So we know we've done okay. All right, everybody okay? Look at number 1 on page 38, and let's do one where your answers aren't in front of you. At 7 a.m., Henry left Austin and headed south at 10 miles per hour. At 8 a.m., James left the same place and headed south on the main road. If James was ahead by 60 miles by 3 p.m. on the same day, what was his speed? Okay, who are we talking about? So let's see what we've got. Let's draw our diagram. James was 60 miles ahead. What do we do with that?
James plus 60. No. Yeah.
Draw your picture. James was ahead of Henry.
So like 60 down the middle.
So James went from point A to point B. He ended up 60 miles ahead of Henry. You see, drawing a picture will help you. So who do I have to add the 60 to?
To Henry.
So the distance of Henry plus the 60 equals the distance of James. Okay, everybody see that? All right, let's see what we have to put in our box. Henry and James. I'm having trouble getting all this on the camera here. Okay, what do we know that we can put in our box here?
The Henry's rate was 10 miles
Henry's rate was what?
per hour.
10 miles.
What else do we know?
The time between them was, for Henry was 6, and the time of day they left.
So how did you figure that, Thomas?
It says Henry left at 7 a.m.
Henry left at 7,
and James left at 8.
James left at 8,
And
Or not.
they ended at 3,
they got there at 3. So how long did it take Henry?
6.
How long, are you sure? 7 o'clock, 8, 9, 10, 11, 12, 1, 2, 3. That's 8 hours.
Yeah.
How long did it take James?
7.
Mm-hmm. What else do we know?
The distance of Henry is 80.
We can go ahead and fill that in. What else do we know? Okay, that's all the information we're given. So let's come over here. What's the distance of Henry?
80.
80, we calculated that out. What's the distance of James? Well, look over here. There's the distance, 7 times this.
So 7 hours.
7.
Okay, so there's our formula. Now what do I do?
Just solve it, so 80 plus 60.
14. 140.
So what's the rate of James?
20.
20? So let's go back over here and put that in our box. The rate of James is 20. So what's the distance of James?
140.
140, there you go. Is that a 60
Yeah.
mile difference? So we're good. Okay, is it making sense at all? Let's do number 2, then I'll let you do one by yourselves. Number 2, we're talking about Gus and Bonnie. Gus began the trip at 6 a.m. at 50 miles per hour. Bonnie began to chase her, should be him, at 10 o'clock at 60 miles per hour. What time was it when Bonnie got within 40 miles of Gus? Okay, we're talking about Bonnie and Gus. Bonnie got within 40 miles of Gus. How do I draw that out? Who went the entire distance from point A to point B? Gus did.
So Bonnie, you start off, you don't finish.
Bonnie didn't make it to the end by 40 miles. Does everybody see that? Okay, so let's go back. So who do I add the 40 to?
Bonnie,
The distance of Bonnie plus 40 equals the distance of Gus. That's the key to these problems. Once you've got that, you pretty much know how to do everything else. Okay, so let's make our box. What do we know to put in our box?
That Gus went 50 miles per hour.
Gus's rate was 50. What else do we know?
Bonnie's was 60 for rate.
Okay, I put Gus in the wrong spot. Gus was 50, Bonnie is what, 60? Okay, what else do we know?
Gus left at 6 and Bonnie left at 10.
Okay, who was behind? Who was late?
Bonnie,
By how much was she late?
4.
So I have to add 4 to Bonnie's time to catch her up to Gus. So Gus's time was Bonnie's time plus the 4. Okay? You've done those before. It's just figuring out who you needed to add the time to. All right, tell me what to do.
Do 8 times time of Bonnie and Gus.
Okay. Now, do we know what rate of Bonnie is?
Rate of Bonnie, 60.
Do we know the time of Bonnie?
No.
Do we know the rate of Gus?
Yes.
Yeah. What is it?
50.
Do we know the time of Gus?
No.
Well, yes, it's
Well,
TB plus
yeah, that's
Right. Now, we've got the same variable. They're both TB, so we're good to go. Tell me what to do now.
You distribute 50.
Now what?
You combine 60 and 50.
Okay, I'm going to bring this 50 TB over. So what do I get?
10
10.
TB.
And I'm going to move that 40 over. And what do I get?
160.
So what's TB?
60. Oh, no.
It's what?
60.
Yeah, 60.
16.
I
Okay.
was just looking at it the opposite way.
Oh.
I was thinking you moved the 160 over. So.
Oh. Okay, so the time of Bonnie is 16. So what does that make the time of Gus?
20.
And what's the distance then of Bonnie?
60.
What's the distance of Gus?
1,000.
Is that a 40-mile difference?
Yes.
So we're good to go. Okay, any questions? Everybody okay? Okay, let's see if you're okay. Try number 3.